Has reduced sulfur content in shipping fuel resulted in increased maritime atmospheric warming? Hello friends, Jim here. Well, has it? There are researchers who say it has. An 80% reduction in sulfur dioxide shipping emissions observed in early 2020 could be associated with substantial atmospheric warming over some ocean regions, according to a modeling study published in Communications, Earth and Environment. This decline in emission was the result of the introduction of the International Maritime Organization 2020 regulation, abbreviated IMO 2020, which reduced the maximum sulfur content allowed in shipping fuel from 3.5% to 0.5% in order to help reduce air pollution. Fuel oil used for large ships has a significantly higher percentage content of sulfur than fuels used in other vehicles. When you burn this fuel, you get sulfur dioxide plus water vapor. Well, you get sulfuric acid. But it produces sulfate aerosols. And the aerosols cool the Earth's surface in two ways: by directly reflecting sunlight back to space or affecting cloud cover. Increasing the number of aerosols increases the number of water droplets that form, while reducing their size, both increasing the cloud coverage and forming brighter clouds, which increase the albedo, thus reflecting more sunlight back to space. Marine cloud brightening is a form of geoengineering where marine clouds are deliberately seeded with aerosols to achieve this effect. Chandler Yuan and colleagues calculated the effect of IMO 2020 on the atmospheric levels of sulfate aerosols over the ocean and how this affected cloud composition. They found substantial reductions in both the levels of atmospheric aerosols and the cloud droplet number density. The greatest modeled aerosol reductions were in the North Atlantic, the Caribbean Sea, South China Sea, the regions with the busiest shipping lanes. They then estimated the effect of IMO 2020 on Earth's energy budget, which is the difference between what's received from the sun and what's radiated back out to space. It's also known as the EEI, the Earth's Energy Imbalance, since 2020. They calculated that the estimated effect is equivalent to 80% of the observed increase in the heat energy retained on Earth over that period. The authors suggest that the substantial model effect of IMO 2020 on Earth's energy budget demonstrates the potential effectiveness of marine cloud brightening as a strategy to temporarily cool the climate. Oh, here we go again, more geoengineering stuff. However, they also warned that the intended reduction in sulfur dioxide emissions due to IMO 2020 potentially causing an inadvertent increase in marine atmospheric temperature is an example of a geoengineering termination shock that could affect regional weather patterns. Well, okay. A couple of items here. So they modeled this stuff here. So they modeled it, and then based on the modeling, they estimated the effect of IMO on Earth's energy budget. And they said that led to an 80% observed increase in heat energy retained on Earth over that period. What I want to know is, did their models include ocean heat content diffusing to the atmosphere? Most atmospheric folks don't include that. Did their models include other sources of aerosols? What other sources of aerosols? Well, I'm talking biogenic. For example, I just saw a recent study, and now granted this is over in the Ural Mountains in the Eurasian continent on the landmass there, but there are biogenic sources of aerosols. So organisms releasing aerosols. And remember, to form a cloud, you just need some sort of hygroscopic particle for which water vapor can then coalesce around. So it doesn't necessarily have to be a sulfate particle. It could be anything. It could be dust, soot, whatever. So, or any, other type of chemical compound. So, in the oceans, we have phytoplankton. Phytoplankton release DMS. DMS, dimethyl, wait for it, sulfide. It's an aerosol. Phytoplankton release sulfate aerosols because the sulfide quickly oxidizes the sulfate. I'll repeat that again. Phytoplankton release sulfide release aerosols with sulfur as the main element. They release aerosols. Recent research shows that when the planet warms up, phytoplanktons release more DMS. And when the planet cools down, they release less. In other words, phytoplankton are a temperature regulatory mechanism for the planet. And the amount that they release is in the vicinity of 10 to the 15 grams of DMS per year. To say the least, that is not an insignificant amount. That is quite significant. So I bet these guys didn't include that. And I bet if you were to include the phytoplankton's role, you would see that the impact of the aerosol is decreased. If you would include the ocean heat content diffusing, you would see that this 80% of the observed increase that they attribute to the aerosol reduction will be actually a smaller value. And just as phytoplanktons release 55 to 80% of atmospheric oxygen, they also release DMS, which regulates the planet's temperature. Now, the concern I have is with the increasing stratification, you will have decrease in net primary productivity, NPP, which will reduce how much DMS is released. We need studies. We're only seeing, preliminary studies as to the estimates of how much DMS is being released, but we need to see studies as to what is happening to the DMS levels that phytoplanktons release as NPP starts to decrease due to increased stratification, because increased stratification without the mixing reduces the nutrients available for the phytoplankton. We need these studies. We need them now. We need them in great detail. So this is what they're reporting. There's a whole bunch of folks that jumping on this bandwagon. Now, I am not saying that reduction of aerosol does not impact atmospheric temperatures. Clearly, it does. What rankles my feathers is when they try and say the reduced aerosol is why we have such high sea surface temperatures. No. Remember, when you have ocean heat content down to 2,000 meters, most of it concentrated in the upper 700 meters or so, it does not heat up the water that much. The specific heat of water is 4 times that of the atmosphere. So if atmospheric scientists estimate that the reduction of aerosol results in a warming of 0.42 C per century, that in no way is reduction of aerosol going to result in a 5 to 7 C increase in sea surface temperature over a couple of years. The physics tells us that's not likely. So you need to look at that. And also, you hear the atmospheric scientists saying that, it's heating up the surface water as AMOC is slowing down. AMOC forms in northern latitudes. In northern latitudes, ocean density is determined overriddenly, more so, by salinity, not temperature. That's in the tropics. It's the freshwater input that's causing the AMOC to slow down. And, they're looking at reduced sulfur content. Another thing is they make an assumption that we stop putting greenhouse gases into the system. Maybe the warming, again, goes back down to this 80%. How much of that 80% is attributed to the continual dumping of greenhouse gases into the system? If reduced aerosols warms the atmosphere by 0.42 C over a century, I think this number is going to be even considerably smaller. And let's not even talk about the fact that the North Atlantic is not exactly the calmest of oceans. So when you have a lot of chops and waves and wind fetch across the surface, stuff like that, that greatly reduces how much heat energy can penetrate the surface, and whatever does penetrate the surface quickly attenuates, follows a rapid exponential decay function. So you're not going to get much heat energy into the ocean that way. You need the mesoscale eddies to do so. And even then, the sun is coming in at an angle, because curved surface the Earth is, so you don't get all of the heat energy entering the oceans as you do in, say, the tropics. So you've heard me criticize the atmospheric folks who keep bantering this sulfur, this aerosol thing as the reason why everything is going crazy. Well, there are other factors. Aerosols is a minor factor, not a major one. You want to know what the major factors are? All the heat energy we put into the system from burning fossil fuel that cause ice to melt, which is the freshwater input, that causes AMOC to slow down. That's what it's all about. So, but, wanted to share this with you so you can form your own, assessments. I've given you my critiques. And, you can do with that as you wish. But anyway, I noticed there was nothing mentioned about the North Pacific. Maybe they didn't study it. Interesting to see what their findings are about that. So, there you have it. Talk to you soon.